Welcome into the field of physics. I'm Mike Tulaski. In this video, I'd like to continue talking about the electron gun. Then I'd like to go into the Farnsworth multipactor tube and then the Farnsworth fusor. Because this whole thing dealing with plasma, how to confine it, and then how to be able to use it, started off back when they were working on things like the TV. It progressed through the nuclear age, and we're seeing how they're still trying to fine-tune it today with how they're trying to engineer their fusion reactors. So let's get into it. Here we go. So like I said before in my previous video on the electron gun, if you were to ask the founder, J.J. Thomson, what an electron is, he would have told you an electron is simply one unit of dielectric induction, meaning that it's being induced from the source, from the dielectric, from counter space, through the 0 point, and manifesting in the space, into the magnetic. Just like at the center of this ring magnet, there's no magnetic field at the center. It's 0G, 0 Gauss, because it's a 0 point tap into counter space, into the dielectricity, which is faster than light. That's the cold end of the spectrum. Out here is where you have all the magnetic field. This is where you have your magnetism. This would be equivalent to the hot end. In between is the 0 point. The 0 point is the way to tap the electricity that exists both in space and in counter space simultaneously. The dielectricity is faster than light. It's the complete opposite of electromagnetism. Electromagnetism would be considered the hot end. The dielectricity would be considered the cold end. It's just like with the fusion. You have hot fusion, and then you have cold aneutronic fusion. Okay, so like I said, this whole thing is misunderstood. An electron is one unit of dielectric induction. The root word for the electron is L, E-L. L simply means source or God, because everything is coming from that source, from the dielectric, and then manifesting into 3D visible reality. The word L is also where we get words like elders, or the elected, or the elite. This is also where we get the word electricity. Electricity exists both in space and counter space simultaneously. The way to tap it is through that 0 point. Just like Eric Dollar will tell you, dielectric side of electricity is the side that represents the faster than light phenomenon. So an RF electron gun consists of a microwave cavity, either single cell or multi-cell, and a cathode. In order to obtain a smaller beam admittance at a given beam current, a photocathode is used. A radio frequency electron gun with a photocathode is called a photoinjector. Photoinjectors play a role in X-ray free lasers and small beam emittance accelerators in physics facilities. An electron gun can be used to ionize particles by adding electrons to or removing electrons from an atom, but we know it's not particles, it's fields. This is used in mass spectrometry in a process called electron ionization to ionize vaporized or gaseous particles. More power electron guns are used for welding, metal coating, 3D printers, metal powder production, and vacuum furnaces. Electron guns are also used in medical applications to produce X-rays using a LINIC. A high-energy electron beam hits a target, stimulating emission of X-rays. Electron guns are also used in traveling wave tube amplifiers for microwave frequencies. And this is when we get into things like boosting this whole deal by using stuff like cavity magnetrons. So this is basically what an electron gun looks like. You have a hot cathode, then you have a vanillite cylinder, and then you have the anode. A photoinjector is a type of source for intense electron beams which rely on the photoelectric effect. A pulse incident into the cathode of a photoinjector drive electrons out of it and into the accelerating field of the electron gun. In comparison to widespread thermomic electron gun, the photoinjector produces electron beams of higher brightness, more packed in a smaller volume of phase space. This is called beam emittance. The photoinjectors serve as the main source for single-pass synchrotronic light sources such as free electron lasers and for ultra-fast electron diffraction setups. The first radio frequency photoinjector was used in 1985 at Los Alamos as a power source for the free electron experiment. It can probe directly or indirectly the molecular, atomic, and nuclear structures of matter and can make material characterizations. The key component of the photoinjector is a photocathode. It's located inside the cavity of the electron gun. It's a 0.6 fractional cell for optimal distribution of the accelerating field. An extracted electron beam suffers from its own space charge fields that determines the beam's brightness. The photoinjector guns often have a booster cell to increase beam energy. The gun's accelerating field is RF waves provided by calaistron or other RF power source. Low energy beams, like in electron diffraction and microscopy, use electrostatic acceleration with DC. Photoemission on the cathode by an incident pulse drum driving laser. The wavelength can vary from 1700 nanometers, which is infrared, down to 100 to 200 nanometers, which is ultraviolet. Emission from the cavity well is possible with laser wavelengths of 250 nanometers for copper walls or cathodes. So this is when we get into Farnsworth and the TV. So the television is a communication medium for transmitting moving images and sound. It can refer to a physical TV set rather than the medium of transmission. And that came out in the 1920s. Then we got into stuff like the plasma TV. Plasma display panel uses small cells containing plasma, ionizing gas that respond to electric fields. The plasma TV ended in 2014. Cathode ray tubes lasted up to the 2010s. The word tele comes from Greek and it means far. The word TV is from Latin visio, it means sight. So Philo Farnsworth was from 1906 to 1971. He was the father of the television, granted the first patent for a TV by the US government. He also invented a video camera tube and the image dissector. As Eric Dollard says, Philo Farnsworth built a multipactor tube, a secondary emission, negative resistance tube. When hooked to a Tesla coil, it exhibits electric oscillations. Probably the world's only real free energy device that anyone ever demonstrated can be reproduced. The Farnsworth multipactor effect occurs when electrons accelerated by RF fields are self-sustained in a vacuum or near vacuum via electron avalanche caused by secondary electron emissions. The impact of an electron to a surface can, depending on its energy and angle, release one or more electrons into the vacuum. These electrons can then be accelerated by the RF fields and impact with the same or other surface. This is what the Farnsworth multiplier tube looks like. So this phenomenon was first observed by French physicist Camille Goutin in 1924 at Nancy, and was identified and studied in 1934 by Philo T. Farnsworth, the inventor of the electric television, who attempted to take advantage of it as an amplifier. The tubes were unstable and short-lived and never went commercial. Called Farnsworth's cold cathode electron multiplier tube, it uses neither grid nor filament. Think of a vacuum tube without a filament or a grid, thus requiring neither an A nor a C battery, which generates high frequency oscillations, and that's the key. It also is an exceedingly efficient detector and modulator. In 1934, they did a radio transmission between San Francisco, Honolulu, and New York. They used a 35-meter channel, 30 milliamps at 1100 volts on the anode. The tube drove a pair of 150-watt tubes in the final amplifier. So Eric Dollard tells this story when he was younger. He was taking these streetlight bulbs from his city and hooking them up to a whole bunch of power. And what he was seeing happen was that inside these tubes, before they would burn out, they would start forming like spiral galaxies in them. They'd start this reaction. And then the tube would just get so hot it'd burn out. So later on in life, Eric Dollard ended up meeting Philo Farnsworth's son. And Farnsworth's son showed him all these tubes that his dad was working on, which had all been like burnt out and stuff because he was trying to keep working on this thing and get it to sustain longer. So this is when we get into magnetic degaussing. Okay, so degaussing is trying to wipe out the magnetic field in a certain area. Just like I said, at the center of this magnet, there's no magnetic field. It's like it's degaussed because it's 0G. That's where the term degaussing comes from. So degaussing or deperming is the process of decreasing or eliminating a magnetic field. It is named after a unit of magnetism. That's where you get Gauss. So they would do this on these warships where they would degauss them before they sent them out to sea so that no magnetic landmines would stick to the ship and blow it up. So degaussing, oh yeah, that's where they started this whole basis thing for the Philadelphia experiment was from that. Degaussing is used to reduce magnetic fields in tape recordings and CRT cathode ray tube displays to destroy data held on magnetic storage. So on these old cathode ray tube TVs, when you would go to hit the power button, it would take just a little bit to start up, and you'd hear this low thud, and then your TV would turn on. Well, that's called the magnetic degaussing for like the startup for the TV. It's a process that it wipes out the magnetic fields on the it wipes out the magnetic fields and destroys the data held on the magnetic storage. So this is where you get stuff like magnetic storage, MRAM. Magneto-resistive random access memory is storage data in the magnetic field. Just like you can store in the Earth's magnetic field and then be able to retrieve it if you had the right equipment. It's bits based on the tunnel magneto-resistance effect, TMR. Its advantages is non-volatility, low power usage, and good shock robustness. So, like I said, it's trying to wipe out the magnetic field in a given area. So Farnsworth come up with this other deal called the Farnsworth fusor. He invented a small nuclear fusion device, the Farnsworth fusor, employing inertial electrostatic confinement, IEC. It was not good for nuclear power generation, but provided a viable source of neutrons. This design has inspired other fusion approaches, including the Poly-well reactor concept. The Farnsworth fusor is an apparatus designed to create nuclear fusion. Unlike most controlled fusion systems, which slowly heat up a magnetically confined plasma, the fusor injects high-temperature ions directly into the reaction chamber. It was first introduced in the 1960s. The first device that could clearly demonstrate it was producing fusion reactions at all. So the Poly-well device, similar to this, you have magnets on all sides. So you'd have them on the sides, on the top, and on the bottom. And they would all stay locked in this configuration. So you'd have basically this setup with magnets all the way around it. Like I said, on the bottom, on the side, and then on the top. And they're trying to fire it through the center to make the reactions happen. So it's the same thing that Ralph Ring was trying to do in the beginning with trying to fire a cathode ray tube directly through the center of the magnetic field. And he kept trying to do it by using more power, and it wasn't working because it was either going to the positive or the negative. What he figured out is you have to pulse it. So once you pulse it, it would go through every time because it's hitting that neutral. So that's how this whole thing's working with how they're trying to engineer their stuff today. Where you have the hot fusion, that's where you get into the electromagnetic end of the spectrum. Where you're dealing with the cold aneutronic fusion, that's when you're dealing with the dielectricity, the faster than light, that's the cold end. So there's two different approaches that are going on, and we're gonna see how this whole thing progresses. So if you haven't seen my previous video on the electron gun, please check it out. If you haven't seen my other videos, please check them out, and thanks for watching. Peace.